Good morning. Today we will be starting the chemistry section of FLP 7. Now in this question they've asked us the total number of sulfur atoms which we will be able to calculate by calculating the moles of sulfur atoms. We will divide it by its respective MR32 divided by the combined MR of sulfur and oxygen, and its SO2 it's about 64. So it gives us the answer of 0.5. We'll multiply it with the number of atoms which are 6 times 10 power 23 to give us the result. D is the answer. In the next question, the weight of a single atom of oxygen. You should know that in 6 times 10 power 23 atoms gave us a mass of 16. So how many would be present in one? We'll simply cross multiply to get the answer. Now in this question, they've asked us the percentage yield. The percentage yield is the calculated by the formula, which is the actual yield divided by the theoretical yield multiplied by the 100. Now, I've already told you that the actual yield is always less than the theoretical yield. So what we'll do is that we'll calculate the moles of calcium carbonate, which will be 25 divided by 100, which will be about 0.25. And by this, by calculating mole to mole ratio, we'll be also calculating the respective moles of calcium oxide. We know that they both have 1 to 1 mole ratio. So we'll be able to calculate the amount of moles which will be obtained after the reaction completes. Now in question 72, as the as the size of the or the shape of the p orbitals increases, their size also increases. In sodium chloride, each sodium ion is surrounded by 6 chloride ions. In this question, you just have to see that in the products, there are lesser number of moles than the reactants. For example, there are 2 moles of ammonia being produced, whereas there are 4 moles of reactants. So it will have a net -2 on the RT. However, because it's written in the form Kp equals to Kc RT, so when we bring it on the other side, it will be changed to Kp equals to Kc whole bracket 1 over 2. A is the answer. In the next question, all of these is the answer. Why? Because we know that Haber's process involves the production of ammonia, and by increasing the pressure, the amount of yield will be forced to move towards low gas volumes, which is the forward direction. Similarly, decreasing the temperature would favor the yield of the reaction because it's an exothermic reaction, and continuous removal of ammonia will also shift the dynamic equilibrium towards the product side. On question 76, this is an exothermic reaction, so it must be completed at low temperature. In question number 77, this is the relationship between pH and pKa. pKa represents the acid component, so it's either A or C. Now, what is the answer? The answer is C. Why? Because we will know that normally it's written in the form pH equals to pK log plus log. Salt is written in the numerator and acid comes in the bottom. However, since it's reversed in this case, the sign will also be negative. Now, what is the half-life? Half-life is the amount of time required for a certain substance to disintegrate by 50% of its original volume or its original mass. So they've told us that 75% disintegrates in 9 years. So how much will 50% will be able to disintegrate? The answer will be 4.5 years. Now in this question, in which ultraviolet different amounts types of radiation and are absorbed and only some are reflected, the instrument that helps us to measure this in the best possible way is the spectrometer. Now, in this question, the rate of the reaction is calculated by calculating the change of in concentration divided by the time taken. So it's 6 times 10 power minus 4 divided by 10 raised to power 1. When 10 comes into the numerator, the answer is D. In question 81, all of these options are correct because the spontaneous reaction is unidirectional. It only proceeds in one direction, it's irreversible and is always real. Now, all of these are enthalpy of atomization. Why? Because you can see that the enthalpy changes. These are endothermic reactions, and in order to break the bonds, energy is required to be absorbed. So these all are correct. Now, in order to calculate the missing question mark, enthalpy change, we just need to know the difference between these two, which is about 110 kilojoules per mole. These dons. Now in question 84, the following equation hasn't been given. However, if it was given in the preliminary text, so the correct answer was manganese is reduced from +7 to +2. You can see that according to the rule that a decrease in oxidation state amounts to a decrease in oxidation number, thus it's classified as a reduction reaction. In question 85, this is the same question which was repeated in the previous FLP. P is the answer. In question 86, which is a redox reaction, the first reaction is a redox reaction. A redox reaction is a reaction in which both reduction and oxidation takes place simultaneously. Now we know that they've shown us four graphs of electron affinities. The correct graph is D. Why? Because we know that there's a sharp decrease in electron affinity for groups 2, 5, and 8, representing beryllium, nitrogen, and neon, which are the elements in each of these groups. Now, the first ionization energy of beryllium is greater than any of the of other groups, which is boron or lithium. Now, in question number 89, they talk about the Vesper theory and the valence bond theory. The VBT talks about the bonding of the molecule, whereas Vesper mainly concentrates on the shapes and geometries of the molecules. So VBT explains coordinate covalent bond formation. VBT also explains the reason for bond formation. Yeah, it explains the reason why bonds are formed. Now, in question 90, out of all these, beryllium is the one which will not react even at extreme hot temperatures because it is extremely unreactive. The most reactive alkali metal is cesium, being at the top of the group. Group and alkali metals are group 1 metals. Now it's 4s2 3d6, this is the configuration of iron. Now in paramagnetic behavior of atoms is due to their unpaired electrons in their outer shells. In question number 94, the oxidation state of iron, you need to know that the entire, basically this bracket needs to be balanced out and should be equal to -3, because over here potassium is +1, so it has a net charge of +3 because it has 3 atoms. So if potassium is +3, this whole bracket should amount to -3. However, we know that this is -6 because one cyanide has a charge of -1. So multiplied with 6 atoms, so iron must amount to +3 so that this can have a negative charge of -3. So iron has an oxidation state of +3. Now, which of the following are cis and trans isomers? Cis means they're identical to each other, and trans means that they're exactly opposite to each other. So the correct answer is A. Now, in question number 96, they've given us three rings shaped atoms, and these are all aromatic hydrocarbons. Whenever you see this ring shape in a 6-carbon atom, this represents that it's an aliphatic hydrocarbon. Now, on question number 97, which type of isomerism refers to the difference in the chain? In the I've said the answer itself is a chain isomerism, which arises due to the difference in the nature of carbon chain because of the difference in the position of the functional group on the relative carbon atom. Now, whenever during the hydration of propane in the presence of sulfuric acid, the final product will be propanol because OH group will be attached to it. Now, they say that a stone is prepared by the hydration of propine. Propine has 3 bonds in it. So, how is it prepared through formation of propan 2? Yes, this is the answer. In nitration, NO2 plus is the electrophile, and you should know that electrophiles mostly have a positive charge on them. Yeah, so the correct answer is that concentrated H2SO4 and nitric acid are used. A is the answer. Now, in the bond that undergoes heteroglyphic cleavage, most readily it would be would be between the atom which have the most difference between of electronegativity between the two. So the correct answer will be A. Now, in Tollens reagent, we know that Tollens reagent is used to denote aldehyde groups. Cyanohydrin of acetaldehyde on acidic hydrolysis. Acetaldehyde is a 2-carbon aldehyde. It will released, so it will release 2-hydroxyethanoic acid. Using sodium bromide, propanal is reduced. It's an aldehyde and it will be always be reduced. It's a 3-carbon aldehyde, so it will be reduced to 2-propanol. Now this is ethanoic acid because this is a 2-carbon atom. So obviously they've asked us that what is X, which is being oxidized to produce 2-ethanoic acid. There are a total of 3 carbon atoms, sorry, because you can see that there are 2 carbons and a single carbon written over here. So the correct answer is, yeah, 1 butene, yeah, 2 butene is what is the answer. Which of the following derivatives cannot be prepared directly from acetic acid? It's acetamide. The final question, collagen proteins are present in tendons throughout the body. Yes, has protein in it. I hope this answers your queries a lot. Thank you.